yesterday. All my troubles seem so far away. Now it looks as though they're here to stay. Oh, I believe in yesterday. Suddenly, I'm not half.
For the first part of our SBS assignment, we use the credit card debt data. First, with your chosen dataset, click Analyze at the top left, then Descriptive Statistics, and then click Explore. From here, find your chosen variable in the list of variables, click it, and move it into the dependent list using the rightward-facing arrow next to the variables list. SPSS by default will use a 95% confidence level, but this can be changed by going to the Statistics button at the top of the Explore dialog box, then changing the text in the confidence interval for mean, then clicking Continue to go back to the Explore dialog box. Then, click Statistics in the display box, then press OK to create the chart shown here, labeled Descriptives. This table contains a variety of statistics used to measure central tendency and dispersion. In our presentation, the confidence intervals are our primary focus, especially the values for the upper and lower bound of the 95% confidence interval for mean. The values in this table, however, are not exact, but are instead shown as a number with a single decimal place, which can be used to find the real value by moving the decimal 4 times to the right. For example, in our table, the mean is 1.9212, but this value should actually be 19,212. If you were to have a negative decimal in your table, you would want to move the decimal 4 places to the left instead. If you wanted to see the actual value in SPSS, you could right-click the table, mouse over Edit Content in the menu that appears, click In Separate Window, and resize the statistic column until it shows the full value. Next, we will create an error bar graph for the confidence interval for the mean of our variable. To do this, click Graphs, then mouse over Legacy Dialogs and select Error Bar from the drop-down menu that appears. For the purposes of this presentation, we will elect to create a simple graph. At the bottom of this box, there is an option for summaries for groups of cases or for separate variables. For this demonstration, we will select Summaries of Separate Variables, then click Define. This will bring up a list of variables. Select the chosen variable for the dataset, which in this case is Household Credit Card Debt, below the box. Below the box where the selected variable resides, there is a box titled Bars Represent, which allows the choice for the error bar to represent the confidence interval of the mean, the standard error of the mean, or the standard deviation. For this demonstration, we will use confidence interval for mean. Finally, click OK, and then this graph will be created. This bar represents all the data shown in the table itself, with the mean represented by the small circle in the center of the bar, and the range of the confidence measured by its 2 lines at either end of the bar.
Now we'll move on to calculate the sample proportion of education levels. To calculate the sample proportion, we must do the following procedures. From the menu bar, click Analyze, Descriptive Statistics, and Frequencies. Find Education in the left-hand box and move it to the Variables box. Then click OK, and a table appears and shows the possible levels of education. As you can see, the table displays differing levels of education that we found from the sample. Next, we'll be using the equation for confidence intervals to determine education levels of the population. The mathematical equation is CI equals P sub S plus minus Z to the square root of PU times 1 minus PU over N. P sub S is the sample proportion, which in this case is the amount of people that have a high school education. Since 25% of those sampled have a high school degree, we can state that the sample proportion in decimal form would be 0.25. Z remains equal to plus minus 1.96 because it coincides with an alpha of 5%. PU is the population proportion, which equals to 0.5 because it is the most conservative number that you can use to get the widest range of confidence. And N equals 100 because it is the total number of people in the sample population. Once we do all the calculations, we are given with the solution of 0.25 plus minus 0.098. This means that the confidence interval is between 0.25 minus plus 0.2098. So we can estimate that between 15% and 35% of individuals surveyed in the sample have a high school degree. Note that in this case, N equals 100. Therefore, the sample size of the survey is not representative of an entire population, so the analysis must be skewed by random chance.
Math is a wonderful thing. Math is a really cool thing. So get off your act, let's do some math. Math, 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 math.